Okay, so this is another section where everything is really intensely hands-on. So let's go ahead and write down your essential question first. What happens when you apply more than one transformation to a figure? In order for you to solve this, any of the questions over here, you have to really use graphing paper and pencil and a ruler. So we're going to do all these questions in the classroom. So obviously the test for this section is going to be on paper. And basically what you have to do is just go through this section. As you can see, I have solved them. But it says over here, given a triangle with the vertices labeled A, B, and C, a point can be added outside. Okay, so then it's telling you to rotate it around 60 degrees. So I already selected my answer here, but you have this blue triangle, and then if you draw a line like this, you can see that this angle is smaller than 90 degrees, so you can guess that this is the correct answer. Because if you tried this one, it looks like 90 degrees, and that's bigger than 60 degrees. If you scroll down a little bit, so this one has a lot to do with common sense, and then you connect these two. Obviously this angle is almost 180 degrees. That's how I already knew that the answer is number one. So when you take an online test or something like this, you have to make an educated guess. Same thing over here. Now after you move the triangle to the red, now it says rotate another 30 degrees. So I used the same method. I drew the line like this, and obviously this is a small angle, so I figured this is a 30-degree angle. But over here from the red to the green, this is a big angle. That's not going to be the answer. Same thing with the third one. When I tried to connect the red with the green, wow, that's more than 180 degrees. So my only logical answer was the first one. But the important thing for you to notice over here is that on top, you had to rotate by 60 degrees. Okay, it says over here. And then what you did after that was rotate by another 30 degrees. So if you look at the first triangle, the blue one, and then the green one, you can basically see that you ended up doing a rotation by how many degrees? Well, you can see that if you were to just draw this, you would see that you made a rotation by 90 degrees, because 60 plus 30 is 90 degrees. And so that is the answer here. You can't really see it, but this one says 90 degrees, okay? So what it's trying to tell you is there are different things that we can do to a shape. We can reflect it, we can rotate it, but sometimes, even though we made 2 or 3 different movements, it looks like it's something different. For example, over here, we reflected the blue triangle into the red. And then what we did over here was we connected another line. We draw another line over here, and then we reflected the red triangle again. And when we did that, we ended up with the green triangle. You notice how if you didn't look at the red one, just look at the blue and the green, you notice how they look the same. Although you reflected the blue triangle 2 times, it kind of sort of actually, if you didn't look at this one and just looked at the blue and the green, it kind of looked like you rotated by this much, whatever the degree would be. I would say it's less than 90 degrees, obviously, right? So that's the whole point, okay? You're trying to do different transformations. You can translate it, reflect it, dilate it, or whatever you want. But the most important thing is, even though you did made many different choices, it might just look like you only did one change. Okay, so then over here, this section is basically just making you many different things. Like the translation over here, they gave you the vector. So what that means is select the image that shows the correct rotation of triangle ABC 180 degrees around point P. So then obviously the answer is going to be the third one that I selected because, well, they drew this one wrong. It's supposed to be like this. I don't know why they did it like this, but it's supposed to be like this over here. But it's okay, because if you see this one and that one is the same. I just wanted you to know that the textbook has a lot of mistakes, and I'm pointing that out to you right here. Okay, so you rotate it, so if you connect it, it's a straight line. If you connect these two, it's a straight line. If you connect B with B, this is also a straight line, okay? So that's how you know this everything is 180 degrees. And once you do that, after you do that, they tell you to go ahead and translate it along the vector. And if you look at the vector, it means what? You got to go to the right by 1, 2, 3, and then go up by 1. So that's what you did. So after I rotated it, now they drew it correctly over here. Then I had to move it to the right by 1, 2, 3, and go up by 1, right? So now the green triangle is the answer. So again, this can be a test question that I give you online, but I think it would be better if I just give you a hands-on test. So it's up to you. You can tell me what you think. But that's pretty much it. They're making you do many different transformations. But in the next section, this is the homework question, and it looks complicated, but it's actually not that complicated. On this side, you can see non-rigid transformation, which means there's dilation. So I want you to understand something. When you multiply only to the x, this is a horizontal stretch. When you multiply only to the y, then that's going to be a vertical stretch. And I would demonstrate this for you in the classroom. Okay, so you can totally see what I mean. So first you're going to do a horizontal stretch, and then you're going to multiply both the x and the y by 1 over 4, but then the symbol for the y changes. That means you also reflect it. Okay, so all of this probably doesn't make any sense to you, but when you come to class, it will. There is another misprint right here. This is supposed to be an 8, because it should be the same over here. I just wanted to clarify that there are some mistakes. And then you have to like click on the points and do all that work. But you know what? I'm going to stop right here because that's the only thing you have to understand before you come to class today. You can do many different transformations, but sometimes all those many different transformations might look like just one transformation, or maybe you did 5 different transformations, but it looks like it's just 2. So you have to try and kind of sort of figure that out. And then in the very last section, what they make you do is they make you explain in words, okay? So what happens if you rotate the square PQRS 180 degrees and then dilate it by a factor of 3? Then you have to actually be able to explain in English. See, you got a predictive effect. You got to say a dilation by a factor of 3 will triple the side lengths. It will also be further from the origin than the pre-image, okay? So once again, what do you have to know? If you have x comma y, and you're multiplying something to the x only, and that's the rule, this is called a horizontal stretch. Basically what it does is, if you have a triangle like this, okay, after you make the change, only the x part will be increased, okay, or horizontal stretch. It means like you stretch it that way, sideways, by 3 times, okay? Now another thing is, if you have x comma y, and the rule is to stretch it, multiply only the y, okay? So the x stays the same, and now this time we're going to multiply the y by 3. In that case, what that means is, if you started off with a triangle like that, after the transformation, your x will stay the same, so the width will stay the same, but the length will be 3 times as long, okay? And this is what we call a vertical stretch, okay? Because we are basically stretching up and down. You see how the triangle is the same width, but then the height went up by 3. Now, finally, the very last thing you have to know before you come to class is, when you have x comma y, and the rule is to multiply both the x and the y by the same number, in this case 2. This is called a dilation. And dilations basically means you have the same shape but different size. Okay, so you can either shrink it if the number that you're multiplying is something less than 1 but still bigger than 0. It still has to be positive. So like a fraction, 1/2, 1/3, 4/5, right? So in other words, if you had a triangle like this, after a dilation, because you're multiplying the x and the y by equal amounts, now what you're going to have is the exact same shape but bigger. So dilations mean it stretches all the way, or it could even like, obviously, shrink all the way. So these are the 3 main things that you have to know: vertical stretch, horizontal stretch, and dilation before you walk into my class, because everything else you already learned it and I know you get it, the translation, the reflection, the rotation, because we did them in class. Okay, and then what we're gonna do is when you come into class, we'll just go ahead and do some of the transformations. We'll do more than one transformation, and learn how to talk about the changes that you see. Okay, and so that's it for today. Please make sure you have this stuff down before you walk into my room. Happy learning. Goodbye.